What do you mean? You can say, what do you mean by shape? You haven't graphed it. True. But we do know that a quadratic function has only two possibilities. Either this possibility with a vertex that is a maximum, and the other option is this with a vertex. No other function has vertex, just the quadratic function. We never talk about vertex in any other function, just the quadratic. The vertex is a minimum. And I know that from the very beginning, whether it's this shape or this shape. Does anyone remember how?
The coefficient of leading power.
You mean the leading coefficient. I agree. So this one happens when the leading coefficient, which is denoted by A, is a negative number. This one with a minimum happens when the leading coefficient is a positive number. Since the leading coefficient in this case is 1, and this is positive, then I know we are looking at a minimum. So the graph will look like this, for sure. Without even graphing, we know that. So the next step is what is called the vertex, which will be a minimum in our case. Anyone remembers the coordinates of the vertex? How do we determine these? How do we get the x coordinate of the vertex?
Minus b over 2a.
Excellent. Negative b over 2a. Awesome. Excellent. And how do I determine the y coordinate of the vertex once we have this? How do I determine this? Let's say it again.
F of x.
Yes, plug it in. Plug it in. Awesome. Very good. Negative b over f of negative b over 2a. Excellent. So let's start with this. Negative b over 2a. The negative is from the formula. Can anyone identify b? It has to be in descending order. Everything is in descending order. Can anyone identify b?
4.
Very good. Can anyone identify a? Silly me, it's right here. So then the x of the vertex is negative 2. So the vertex has x coordinate negative 2. Again, how do we find the y coordinate once we have x?
Plug the negative 2 in.
Plug in negative 2. So f of negative 2, careful, negative 2 squared, that has to be in parentheses, plus 4 times negative 2 and plus 3. If you omit parentheses or if you plug it in the graphing calculator without parentheses, you will get a totally different number. It'll be a big surprise. So this has to be 4. Negative 2 times negative 2 is 4. This is negative 8 plus 3, 7 minus 8, negative 1. Can anyone at this point give us the range of this function? You can say we haven't graphed it. I haven't seen it. True. But you can give me the range. From the smallest y value till the largest y value. Can anyone identify?
-1 to infinity.
Very good indeed. That is for sure the minimum value. Excellent. Great job. Okay, number 3. X-intercepts. So let's analyze this for a moment. For a minimum, the function can look like this and have a minimum, can look like this and have a minimum, or the function can look like this and still have a minimum. Which of these three, only one, is our case? Is it number 1? Is it number 2? Or is it number 3? And how do I know?
Number 3.
Perfect. How do I know it's number 3? from the vertex, because the minimum value is not a positive value. The minimum value is not 0, but the minimum value is a negative number. So it's no and no and yes. Why would I ever think of this? I don't want to waste my time. X-intercepts in this case, they exist or they don't?
They exist.
They don't touch the x-axis. The function does not touch the x-axis, right? In this, oh yes, you're right for this case, for our case. But in this case, the x-intercepts don't exist. The function doesn't touch the x-axis. What about the x-intercepts in this case? How many?
1.
Exactly. And it would be 0. The y value will be 0, so that's not the case. So it must be this. The two x-intercepts exist, so I have to calculate them. How do I find the x-intercepts? What do I need to write to find the x-intercepts?
Make the y 0 and all.
Indeed, indeed. Thank you. 4x plus 3. Can anyone quickly factor this for us?
Plus 3 plus 1.
Very good. X plus 1, x plus 3. Or use the quadratic formula if that's what you want. Can anyone give us the two x values?
-1 and -3.
Good. Can anyone now give us the ordered pairs that represent the x-intercepts?
-1, 0, -3, 0.
Of course. Silly question. Thank you. Good. Now we want the y-intercept. This is always going to exist. How do we get the y-intercept for this function or any function?
Make x is 0.
Very good. This is always easy. F of 0.
Three.
Good. Awesome. What is the ordered pair?
0, 3.
0, 3. The last two are words. So number 5, axis of symmetry. Yes, this is a symmetric graph. And this is always x of the vertex, which is -2. You already gave me the minimum. Minimum value is -1. And you already determined the range for me. So the range is -1 to infinity. So these are just things to list and use right now. So here's the graph. I start by plotting the vertex, -2, -1. Next, I continue with the axis of symmetry, which is not part of the graph. It's a dashed line. Now I plot the x and y intercepts. So 0, 3, and -1 and -3, they must be symmetric with respect to the axis of symmetry. And now I graph the parabola. I have to graph it as symmetric as I possibly can. My graphs will never be perfect. So I have to write somewhere what I graphed. X squared plus 4x plus 3. So all these steps should go in your separate notes for posterity, for tests, for final, for whatever. All those steps should go in. Any questions for me? Sorry, any questions? Okay, last topic here from chapter R is demand and supply functions. Demand and supply functions. Okay. So the x-axis has number of units, or if you want, quantity. The y-axis has price. So if we look at a low price, so let's start with the demand. If the price is low, would you agree that we can afford to buy many units? If the price is high, we afford to buy as little as possible. So in other words, if the price is low, we can afford a lot in quantity or number of units. But if the price is high, we afford very little, very few units. So here's an example of a demand function. So price is high, we afford 1 unit or 2. Price is very low, low price here, low price, we can afford a lot more number of units. So the demand is always a decreasing function. Higher the price, less we can afford. Lower the price, more units we can afford. Now, what about the producer? From the producer point of view. From the producer point of view, at a low price, they want to sell very few units. So when the price is high, they really want to sell many units. So this is the supply function. High price, they want to manufacture and sell a lot. Low price, they don't want to sell too many. This point is a very important point. We consider that at this point, everybody is happy. We are happy with the price and we can afford a certain number of units. They are happy with the price and they are willing to produce and sell it to us at that price. And this point is called the equilibrium point, when everybody's happy. So I would like us to work on a problem like this. And I'll let you choose. So as you noticed, the supply function is increasing. That's what they want. So this is the supply function increasing. Here's the demand function. Here's the supply function increasing. Here's the demand function. Okay? Demand function decreasing, supply function increasing. And so on and so forth. So please choose any of these so we can find the equilibrium point. And that's the end of chapter R.
I have a question.
Yes, please.
So for the for these type of graphs, is quantity like how many things are being sold?
No, how many units we can afford at a, yes, very good question. How many units we are willing to buy, how many units of the same product we are willing to buy at the price of $5 per unit. So if the price of a gallon of gas is 20 cents, I can afford to drive more. I can afford to buy more gallons. If the price increases to $10 a gallon, I will only restrict my driving and buy less number of gallons because I cannot afford it. The price is too high. So I'm going to buy only, I'm just making numbers up. I'm just going to buy 10 gallons per month because that's all I can afford at the price of 5 a gallon or 6 a gallon. But if the price decreases, to, I don't know, $2 a gallon, then I can afford to drive more. I can afford to buy more gallons of gas. Does that make sense? Is it better?
I think so.
Okay. Very good question. So let's choose a demand and supply and find the equilibrium point when supposedly everybody is happy. Which one?
79.
Which one? Did you say 79?
Yeah.
Okay, very good. So we have P 5 over Q. The notation here is really silly. I'm using a silly notation in my opinion. Okay, so this is the price. So it's P, and the quantity is Q. So they're asking us to find the equilibrium point. Fine. So in order to find the equilibrium point, notice that this is the same thing with this. So these two have to be the same, right? So P equals 5 over Q. Also P equals Q over 5. So then 5 over Q must equal Q over 5. Now I hope you remember this is called a proportion. When we have only one fraction, the equal symbol, and one fraction, nothing else. If I have 5 over Q plus 1 equals Q over 5, I'm going to erase this, you don't write it. This is not a proportion. So I cannot apply the procedure that I'm going to apply here. Anyone remembers what we can do in a proportion and in a proportion alone? There's some procedure, a quick procedure that we can do, only in a proportion. So here's your hint.
Multiply the cross.
Very good. Cross multiply. Cross multiply. How much is Q times Q?
Q squared.
Very good. How much is 5 times 5?
25.
Good. Very good. We know that this is quadratic. It has to have two solutions. So what are the two solutions in this case? If you move and factor or take square roots, please give me two solutions.
Negative 5, 5.
Very good. After I write this, which is correct, I will have to say only Q equals 5 units. I cannot purchase negative 5 units. So the solutions are correct, but they don't apply, other than the positive solution does not apply to our situation. So if Q is 5 units, oops, if Q is 5 units, how much is P?
1.
Very good. 1, which means $1. So now the equilibrium point is always X, which is quantity, and price, remember? So here is Q and here is price. Q is 5, comma, the Y variable 1, and this is it.